As the last example of this topic, I will talk about BOM. When we make some products, these products usually this is assembled using some assemblies or parts. For example, to make a bicycle, we have a frame, wheel set, chain, pedal set, handlebar. And to make a wheel set, for example, we have to make a front wheel first and the rear wheel. And further, to make those front wheel, we need bolt and nuts. And also for frame, we need bolt and nuts. And inside, in parentheses, how many parts are needed. So here is the example. So a little bit more simplified example, if I list up, for example, here A, to make A, let's say we need to make a B and a C. So B and C are assembled to make A and the product. And to make a B, let's say we need D and E. And to make a C, let's say we need to use again D. So like D is similarly here, bolt and nuts, it can be used not just for one parent, but it can be used for many assemblies. So if we have this kind of hierarchy, it's similar to employee hierarchy, but there are some differences. The key difference here is, given one parent like this, we have many children. So like we have one supervisor, there were many supervisees. That's the same. However, now if you pick one lower level item, let's say we pick B, we have one parent A. If we have one parent A, but if you pick B, B is parent, but at the same time, C is also parent as well. Okay, so given these examples, let's say there is part, but this part table, we use this part table in two different ways. One is a parent and one as a child. So very similar to supervisor and supervisee in the employee hierarchy. So let me just list up all those parts, both in parent and child. So we have A, B, C, D is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So let me say there is A, B, C, D, E. And A, B, C, D, E. So if you consider the relationship, one parent, like A, has B, C. So parent has many child. But now, the other side, child, when we pick one child, previously supervisee has one supervisor, but now one child item can have either B and C. So there could be many parents. Now we have problems because here, for example, child, if you want to describe parent here, not just one value, for example, for D, you have here both B and C. So we cannot put two values here. And this kind of many relationship is not allowed since we cannot implement it using foreign key. So what we have done, actually we added associative entity in conceptual modeling. So similarly, here, we need to break this many relationship, and we cannot use this foreign key in the child table, but instead we have to add one more table, the matching table, and let's name it as assembly, because we are matching. So here, let's suppose name is assembly, and we need to describe the matching of one parent and one child. So one parent has many assembly, one child has many assembly, but one assembly is describing one matching child and one matching parent. So what assemblies we have in this example? Parent first A to B. So A is parent, B is child. Parent A, children C. So A is parent, children C. B is parent, then we have children D. B is parent, we have children E. C is parent, we have children B. So this is our assembly matchings. So by keeping this assembly as associative entity, we could break the many relationship. And the first part is describing parent, and second column is describing child. So given one, this assembly, we are describing only one parent and one child. And each parent and child, there are many assemblies and many assemblies. So we have this assembly as associative entity or matching table entities. But now, one more thing you need to consider is, since both parent and child conceptually we describe here, this is just similar to employee, it's all part. So employee actually describes both the supervisor and supervisee. Similar here, part is describing both parent and child. And we can combine this together as one table. But conceptually, you can use in two different ways. So that's why we have here part and here assembly, but we have two relationships from part, one as a parent, the other as a child. So we have two relationships, but we have only two tables. But when you make SQL, just consider one as a parent and one as a child, and at the center, just assume there is assembly, and consider this relationship from parent to assembly, child to assembly. Since part is used in two different ways, similar to previous examples, we may need to use alias. So using alias, we can easily develop SQL statements in this complex case. So let's try to understand with a little bit more realistic data. So here, parent and child is given. So for number 10, what is that? It's a bicycle. So the end product we are making. And to build this bicycle 10, again, how can we find 10 is bicycle? By matching this 10 with this part ID. And we need those child. So how can we find the details? Now you will match this child PID as foreign key, and you will find here primary key and matching. For example, 11, what is that? It's a frame. So if I draw the hierarchy to make bicycle 10, we need like 11, 12, and so on until 17. Now to 11, to make 11, what is 11 again? Frame. We need 18 and 19. So what is 18? Bold and null. So here we need 18 and 19. And to make 12, we need 13 and 14. So here 13 and 14. I will skip some part. And here to make 17, what do we need? 18 and 19. Like this, we can restructure the BOM. And just note that, different from employee, as I told you several times, the same child, like 18, there could be different parent. So what is 18? 18 is board. Board is used to make 11. 11 is frame. But at the same time, board, same part will be used to make handlebar as well. Before we jump on SQL development, in your note, actually you will find the create table statements for part and assembly. Note that the part table is pretty simple, primary key, part ID. But for assembly, we have a primary key that is composite key, parent PID and the child PID together. And also, look at the foreign key, two foreign key. Parent PID and the child PID both references part ID. However, you have to remember when parent PID is reference part, the meaning of this part physical table is parent part. And when we reference child PID, this part, we read this part as a child part. Okay, so this is how to create table. So run it. And also there is data set, insert part, and assembly. So add all those data in your tables first. Okay, so you will have this data set, part and assembly for the bicycle. And let's look at the first question. So here, first query, list the product description and the cost of each component of the bicycle. So bicycle is a parent, and then we want to look at all the parts. So here in this data, how can we use this? So we will look at bicycle. So at that time, we are reading this part as a parent part. So we found the bicycle in part description. So there is part ID 10. But using part ID 10, we want to find all the components. So what we have to do? That time we are matching this part ID with assembly tables. Which column? Parent PID. So when parent PID is matched as 10, we have here child ID. So this child PID 11, 12, 15, 16, 17, but we do not have details. So what we need to do is to get the details for this child part, this child PID column must be matched with part ID again, but this time we are using this part as children. So for example, 11 matched with 11, and you can get the details. Oh, this is about frame, and there is a cost. So we will make two join statements. First part ID will be matched with the parent PID for bicycle, and all those children PID will be matched again with the part ID. So let's develop SQL. Okay, so let's start with the select, and what we want to show is a part description. So the column name is part description, DSC, and also we want to show part cost. From we are using part table, but we are using part table 2 times, and in addition we are using assembly table. So similar to employee, we are using same part table 2 times, therefore we need to use alias. So let's say it is a child, let me say, and the second part, when we call this, let's use the alias parent. First of all, if we use alias child and parent, since part description, part cost will be in this part table 2 times, it's ambiguous. So you need to qualify. What we are interested in, child item. So child description, and you have to specify it's child part cost. Now, the most tricky part is join condition. So what will be the join condition? So join condition is we match it. So here part ID. So let me say. So here part ID has been matched with assembly tables parent PID. So let's say parent PID. And we match the part ID one more time. Match it with not parent PID, but child PID. So we have 2 conditions. Now question is, when you match parent PID in assembly table, are you looking at child table or parent part table? We are looking this parent as a parent part table, and the second one is child part table. So child alias is used to qualify. So child part ID. So we made the join condition, and we can show all the child descriptions. But we have one more condition. What's the condition? We are looking for part description, and the part description is bicycle. So let's say it's a bicycle. So here BICYCLE. But again, for this part description, we need to specify what? The qualifier. So in this part description, is it child part description or parent description? It is parent. So you have to specify this with the parent alias as a qualifier. It seems to be complex at the beginning, but actually using alias parent and child, we are using 3 tables with 2 join statements that we have discussed already previously. Let's test it. Copy. So here is the list of part description and the part cost. This is for child items. Okay, suppose if I ask the same question in your exam, then I may try to make it a little bit challenging. So instead of using obvious alias like a parent and child, I may use P1 and P2. And here question marks, let's suppose you need to fill in those blanks. Then you can get some hint. What does P1 means and P2 means? Because here in this highlighted, I already filled in P1. This one is matched with the child PID of assembly table. So from this, you know that P1 means child. So here in this question mark, what we are describing child. So we will say it's a P1. And we are describing child cost, so it's P1. But now the meaning P2 is parent, so parent PID of assembly table must be matched with P2. And here description bicycle, is it child or parent? Parent, so you have to know that it is P2. Something like that. With some hint, you will figure out the meaning of alias, and I may ask you to fill in the blanks. So be ready for the exam or test by being familiar with this kind of question format. One more note about this question is I can make a equivalent statements using subquery. So in this approach, suppose I want to get all the child PID that is used to make a bicycle. So in this approach, let's say I found the part as a parent and I found the bicycle's ID is 10. Then I will go back to assembly table and I will use parent PID 10 and I will just get the list of child PID. And using this list of child PID, I will read the part table and I will just match that list of child PID. Okay, in this approach, we are going to select the child PID from two tables, part and assembly. But note that we don't need to use alias because we use just the part once as a parent item for bicycle. And by looking at assembly, by matching it, we can get the list of child PID. So here, the condition is definitely we need one join condition. Join condition is part ID must matched with parent assemblies. Which ID? Parent PID. Because we look at bicycle's child PID. And one more condition is this part description must be bicycle. So I will just copy this part. So here. So if you run this, what you will get? List of child PID to make a bicycle from the assembly table. So let's test this statement first. So here is the list of child PID that we have expected. So 11, 12, 15, 16, 17. So now the result is a list of this child PID. If we have this outside what you can develop, we can develop another statements and we want to show part description cost. So from part tables. So here, let me start with select part description, part cost from part. But note that in this case, part means what? Just a child part. And this child part, we have a condition. So where there is no join condition in this case, we are just reading part table only. But this part ID must be where? In the list of child PID that we got here on the above. So if you have a list of multiple values, it must be combined with what? In statements. And how can you make a list? Inside parentheses, we can just put this upper selected statements. So let's copy and paste here. So if you run this, you will get the same result. So you will get exactly the same result. Note that in this example, we did not use alias, but we made two table join statements to get the list inside. And outside, we use part table as a parent, and we are reading just a simple one parent part table, and we check whether part ID is in this pre-built, list of child PID. Okay, finally, the last example of this topic. So list the parts that use boards. List the parts that use the boards. So let's understand the question first. So here, go back, and the boards is used. So boards are children. So boards, how can you find the boards? So here, using the description, board is part ID 18. So this 18 is in assembly table child PID. So if you look at 18, 18, 18, 18, 4 times you will see. So these boards are used for 4 different parent. So what's the parent now? 11 and 13 and 14 and 17. So these are parent of this child item board. So we want to list those parent items that are using boards as children parts. So let's try to find it. Okay, to solve this, we will use part table 2 times, one as a child, the other as a parent, similar to the previous example, and we join this with assembly. First, the part description. Are we showing parent part description or child part description in this case? Actually, this time we are showing parent because we want to know, items that use boards as children. And then what's gonna be the conditions? First, let's talk about to join condition. Let's repeat one more time. We need to join parent part ID with assembly's parent PID. So let's start with this first join condition. And the next one is child. So when we use part table as a child, we need to join this with assembly table's child PID. So let's add the second join condition like this. And finally, we are looking at the part description boards. But in this case, it's not parent description, but it is child description. So we have to say, oh, I'm sorry, there is child typo. So this is child part description board. Okay, so let's run it. So here is the result. So these are 4, item parts, actually parent parts that use boards as a child part. So even for those kind of a little bit more complex query, if you understand the conceptual model well, like a part, conceptually we use this as parent and child. It's just very similar to a typical one-to-many relationship with associative entity. So this is about topic 6, and we have just one more topic left. And in that topic, based on what we have learned, there is nothing new, but based on what we have learned, we will do some more practices. Thank you for watching.